Here we have two different investments and we want to determine when the two accounts will have the same balance. In this section we're going to use technology to help us do this. Later we'll look at how we could actually solve an equation like this. So looking at the first bank, so we'll call this one bank number 1. We're told that $8,000 is invested in an account at an interest rate of 9.2% per year, compounded continuously. So that word continuously is going to be the key here for how we represent the money that we're making in bank number 1. Whenever we see the word continuously, we're going to use the function in the form AE to the RT. So we want to use that base of E anytime we're thinking about continuously compounded interest. So some things that we know: the initial value or the amount invested is $8,000. Our interest rate of 9.2%, we will change over to a decimal, becomes 0.092. Time is what we're going to be trying to figure out here. And then for bank number 2, we're told that $10,000 is invested in a bank account at an interest rate of 3.1% compounded annually. So the word annually is key here. This tells us to use the formula where we take our initial amount times 1 plus r over k to the power of k times t, where k is looking at what type of interest period we're looking at it. Is it compounded annually, monthly, quarterly, daily? That's going to determine our value for k. So here A is equal to $10,000. R is 3.1%, so it's a decimal, 0.031. And since we're compounding annually, our k is just equal to 1. So we want to know when the amount in bank number 1 is equal to the amount in bank number 2. So bank number 2 is starting with a higher amount, but it's at a lower interest rate. So plugging into each one of our formulas, we want to be able to solve when is 8,000 times e to the power of 0.092t equal to 10,000 times 1 plus 0.031 over 1 to the power of 1 times t. That right-hand side, just to make things easier, we could simplify a little bit. So it's really 8,000 e to the 0.092t, and this side is 10,000 times 1.031 to the power of t. So we're told to determine graphically using technology. So this is a clue to head either to our calculator or to Desmos to then plug in each of these as two separate equations in our calculator. So if you're using your calculator, I'm going to put in one side as my y1 and one side as my y2, and then I'm going to look for the point of intersection between those two. So let's head to our calculator and look at how to do this. So as y1, I'm going to enter in the left-hand side of my equation. So I'm going to put in my 8,000. To get the e on your graphing calculator, it's going to be second and then the natural log button gives us that e with the exponent ready to type in. So 0.092. Instead of t, I'm going to go ahead and use the variable x just when I'm working here in my calculator. Then on the right-hand side, I'm going to put my y2 as 10,000 times 1.031 to the power of, I'm going to use x here as well. So we've got the left-hand side of our equation as our y1, right-hand side as our y2. Now if you just hit graph at this point, we don't really see much on our graph. So we're going to need to adjust our window quite a bit here. So looking at our inputs and outputs, our x's represent time, so I'm going to use 0 as my x minimum. And I'm going to start with just 50 as my x max. We can come back and adjust as needed. I'm going to make my x scale every 10, so the tick marks will be 10 units apart. Now for my y's, I'm going to start at 0, but think about your y maximum. Your bank number 2 account is starting at $10,000 and increasing from there. So we definitely need to make sure that our y values go beyond $10,000 and maybe quite a bit past $10,000. So I'm going to start with $100,000 and let's just see what we see. We may need to adjust quite a bit more. So for my y scale, I'm going to go ahead and do 10,000. So now let's hit graph, see what we see. So you can see our two curves. So the blue curve is the one that represents our Y1. It's starting at that lower value and increasing. Our red curve is starting at $10,000 but increasing at a slower rate. So we can see our intersection point here on our graph. I now want the calculator to find that intersection point for me. So I'm going to head to my calculate menu. So I'm going to do second and then trace and pick option number 5 for intersection. So it's going to ask you if this is the first curve, just hit enter to say yes. It'll say, is this the second curve? Just hit enter to say yes and enter again for the guess. It'll move the cursor to that intersection point and then we can find our values. So this is telling us that an x value, which x really represents our time here. So after about 3.63 years, the y values, the amount of money in each account, will be $11,171.98. The problem asked us to round to the nearest year, so we'll take our 3.63 and round that up to 4 years. So our answer to the question of when will the two accounts have the same balance will be 4 years.